Solar cells. You see them on all kinds of satellites. Solar cells provide power so satellites can do all the cool things they need to do. But how do you know your solar cells will work the way they're supposed to in space? At Aerospace, our scientists test the performance of solar cells using a piece of lab equipment that simulates the sun. The tricky part is that manufacturers are constantly making new solar cells using new technology, and each cell type reacts differently to lab-simulated sunlight. The team needs real sunlight to test out some reference solar cells, which they can then use to adjust and calibrate their solar simulator. But unfortunately, access to sunlight is not as easy as hitting the beach on a summer day. The cells need to be exposed to sunlight above the ozone layer, because when they're actually in space, there is no ozone layer. So that means they need to be tested about 22 miles above the Earth. But how do you get a solar cell up so high and then get it back in your lab so you can calibrate your equipment? Traditionally, scientists use either a large, high-altitude balloon or a plane. But because the test equipment is large and bulky, it takes a balloon the size of a football field. Some scientists from Aerospace saw these challenges, and they came up with an innovative solution. The team, using funding from NASA, figured out how to shrink the solar cell test platform to the size of a quarter. They call it the Aerospace Measurement Unit. It's tiny and light, so the team can use a smaller and cheaper balloon that can be flown more easily and go up to 22 miles above the Earth. The team has patented their device, which they've now flown several times at a low cost. It seems the Aerospace Measurement Unit could open doors for better solar cell testing in the future.
Aerospace has solved one of the greatest challenges facing satellite development today, and we've done it with this device. What you're looking at is a solar cell laboratory on a chip, and what it does is tell us how much power is produced by a solar cell. We measure the performance, and then we can accurately measure the performance of that cell on the ground.